All right, we want to introduce one last example, and then we'll see how it will lead us to. Um, okay, so how do we set up the double integral in its iterated integral form over this domain D, such that this D the is enclosed in the circle of radius 2 with the center at the origin. Well, this doesn't look very difficult. I guess we could draw the illustration first, and to see what we should have. No, I may not be able to draw a very good circle. Yeah, so let's just take it. All right, so how do we represent this domain D? Well, first of all, do we know how to represent the curve of a circle with the radius 2 and the center at 0, 0? I think we should be really familiar with that. But if you don't, let me just remind you. This is the equation we should have, right? But then the question is, with this, all right, with this circle of radius 2 and the equation we were just writing down, then if we want to treat this as, for example, type 1 region, what do we need to do? We need to find the upper bound and the lower bound for the y variable, right? And always the x is bounded between -2 and 2. So -2 and +2 for x is quite obvious. So the domain D, if we treat this as a type 1 region, it's quite obvious x is between -2 and +2. But then for the y, things are a little bit tricky. And we have to, it seems we have to distinguish the lower half and the upper half. So we need to solve y in terms x from these equations. How do we do that? Y squared equals 4 minus x squared. So y equals plus or minus square root of 4 minus x squared. So obviously the top piece is y equals positive square root of 4 minus x squared. This bottom piece is y equals negative square root of 4 minus x squared. So we can see the y variable is bounded between the positive square root of 4 minus x squared and a negative square root of 4 minus x. So the double integral could be written as, well, obviously here we choose to integrate y as the interior integral variable, and x will be the variable for the exterior integral. So x is between -2 and positive 2. And y is between what? Well, y is between negative square root of 4 minus x squared and a positive square root of 4 minus x. This is not too easy, right? But let's think about it. the domain D is indeed from here. Indeed, we can write this as x squared plus y squared less or equal to 4. All right. And one thing we should notice in the polar coordinates, let's write it in polar coordinates, x squared plus y squared equals 2 squared can be converted to what? Remember, r equals square root of x squared plus y squared. But from here, we see can be converted to, I think this is r squared, right, equals 2 squared, which means, so x squared plus y squared equals 2 squared is actually converted r equals 2, which is so simple. All right, so now we can see the domain D could be written in terms of the polar coordinates r and theta, right? This is indeed telling us r is less or equal to 2 because r is always assumed to be bigger than 0, so that is why we have this. And how about the theta? Remember, the theta is covering every point inside of this disk, so theta is between 0 and 2. So obviously, if you represent this domain D in the polar coordinates, it's much easier because both of those limits for r and theta are constants. So this may tell us or inspire us to actually write or think about it, write the double integral in this polar coordinates somehow. Okay, we will do that in the next bit.